Hello everyone, welcome back to our mathematics lesson. So today we are going to learn or continue on our topic on similarity. So previous lesson we have learned that how to calculate area for a similar plane figure or 2D shape. For example, a triangle, a square, rectangles, and circle, and many more. So this time we are going to learn how to do calculation for similar 3D or similar solid. For example, we have cube, cuboid, cylinder, cone, and many more. Alright, so get ready with your notebook and let's start with our lesson today. Okay, so by the end of this lesson, you should be able to apply the methods for a similar solid and how to do the calculation, and then solve problems involving volume and surface area. So the first step is that you need to highlight the key information given, whether it's a length, it's a similar, what cube, what shape, or what solid it is, and then you have to apply formula of a surface area or a volume, and then you have to solve the problems, and lastly is that you have to always double check your working and answer. So today we'll be learning on surface area and volume of a similar solid or 3D. So for a solid, example of solid is that we have here a cube, cylinder, and a cuboid. This is what we call solid or a 3D. Okay, so for a solid, we can calculate the surface area and also the volume. Okay, for surface area, for example, we have these two cuboid here, which is a similar cuboid. So the ratio of their corresponding side, which is A, is to B here because it is a similar. Hence, we can say that the ratio of their surface area is A square is to B square. So the corresponding lengths are L1 and L2, and the corresponding of surface area are surface area 1 and surface area 2. So we can say that surface area 1 divided by surface area 2 is equal to length 1 divided by length 2, close bracket, square. Alright, so remember, if it's a surface area, it must be a square here. It's always a square. Alright? So, how about volume? Okay? So, for example, we have these two cuboid also. So, the ratio of their corresponding side is A is to B. So, we can say that the ratio of their volume is A cube is to B cube. So, the corresponding lengths are length 1 and length 2. And the corresponding volume are V1 and V2. Hence, the formula is V1 divided by V2 is equal to length 1 divided by length 2, close bracket, cube. Alright, so remember, if it's a volume, it must be power 3 or cube here. Whereas for surface area, it will be a square. Okay, so let's try some example on how to apply this formula. Okay. Find the unknown volume. Units of length and volume are centimeter and centimeter cube respectively. Okay, so if it's a volume, then we have to use this formula. Alright, so let's start with the first one first. We have two similar cuboid here. We have V1, which is unknown, with a side of 4, corresponding to V2, side of 6, with the volume of 180 centimeter cube. Okay, first, we apply this formula and then we insert all the information given inside the formula. So we have V1 divided by 180 is equal to L1, which is 4, corresponding to 6, close bracket, cube here. Okay, and then simplify and also cross multiply, you'll get your answer to be 53.33 centimeter cube. Okay, so the volume of the small cuboid is 53.33 centimeter cube. Alright, so now pause this video and try to solve question B and question C. Alright? Okay, so I believe you have done this two already. So let's check your work. Alright, so in this case, the missing volume for question B is V2. So you insert this formula and then insert all those information here. Then you'll get V2 to be 1555.2 centimeter cube. Alright. So next. Okay, so in this case, the missing volume is also V2. Once you insert the numbers, you'll get your answer to be 1800 centimeter cube. Alright, please check your working and make sure you got the correct answer. If it's incorrect, please double check and review back, or you can ask me, okay? So that is how we use the formula here to find the volume for a 3D shape or solid, okay? So let's proceed to example 2. So in this example, we are using this formula also again. Find the unknown length. Units of length is centimeter. So in this case, all the volumes are given. However, we have to find or calculate the unknown length. Okay, so let's try question A first. We use this one and then you insert all of this information. So then you get here, right? So once you get to this step, you want to find the value of x. So you have to move cube to one side and it become a cube root. Once you calculate this one and cross multiply, you'll get your answer to be 12 centimeter. Okay, please check again the working here also. So now I want you to pause this video again and try to solve question B and question C. Okay, so I believe you have done question B and also C for example 2. So let's check your working and answer. For B, you get your volume or your length x to be 28 centimeter. And for question C, your answer should be x is equal to 12 centimeter. So please check your working and answer. And if you got incorrect, please double check here or you may ask me. Alright? So now, that is a simple questions on how to use the formula to find the length, the volume. Okay? So now let's proceed to example 3. The ratio of the base area of two similar solid copper cylinder is 9:16. Find A, the ratio of the radii of the base of the cylinder, B, the ratio of the volume of the cylinders, and C, if the mass of the smaller cylinder is 540 grams, find the mass of a larger cylinder or the big cylinder. So in this case, we have two similar cylinder. Okay, and the ratio is given with this one. Okay, so let's try to do the first question. The ratio of the radii of the base of the cylinder. So in this case, we have to find the ratio of the radius for two cylinders. So we have to make use of this from this ratio of the base area. So we know that first we have to let r, small r and big R centimeter as the radii of the cylinder. Okay? So we know that the ratio of base area is equal to R square is to big R square because it's in area. Okay? So we can say that 9:16 is equal to R square is to R square here. Okay? Since we want to find the ratio, okay, so what we need to do is that we move the square to one side and become a square root. And then this answer should be, the ratio is 3:4. Okay, so this is the ratio for the radii of the base of the cylinder or the radius. Okay, so proceed to the next question. The next one, find the ratio of the volume of the cylinder. So we know that this is the ratio of the radii of the base of the cylinder. Now we have to find the volume. So make use of this answer, the 3:4. So we key in, as we know that ratio of the volume is R cubed is to R cubed. So we key in the ratio, which is 3:4, and become 3 cubed is to 4 cubed. So you get your answer to be ratio of volume is equal to 27 is to 64. Okay, because it is in volume, so it must be to the power of 3. Okay. Next, now we have to find the mass of the big cylinder if the mass of the small cylinder is 540 gram. Okay, so the mass of the cylinder is proportional to its volume. So we can say that the mass of the cylinder divided by the mass of big cylinder is equal to the volume of the small cylinder divided by the volume of the big cylinder. Once you get this one, key in all the information given, and then you'll get to be 540 divided by mass of big cylinder is equal to 27 out of 64. Alright, once you get to this one, all you need to do left is that cross multiply, and you'll get to mass of big cylinder is equal to 1280 gram. Okay, so this is how you calculate the mass of big cylinder. So that is one of the example problem solving. Okay, so if you find it confusing, please review back the working. Okay, so now let's proceed to example 4. This example 4 is inside your notebook. Okay, so we have cylinder X has a base radius of 4 cm. A similar cylinder Y has a base radius of 8 cm. First, what is the ratio of the heights of these two cylinders? Give your answer in the simplest form. And B, if the surface area of X is 50 cm cubed, what is the surface area of Y? And lastly, if the volume of Y is 64 cm cubed, what is the volume of X? Okay, so this is example 4. And then the next one, example 5. The diagram shows a cup in the form of inverted cone of a height 18 cm and base radius of 7.5 cm. It is filled with water to a depth of 12 cm. Express your answer in terms of pi where applicable. Find A, radius of water surface, which is here, and B, volume of water in a cup, C, additional volume of water required to fill up the cup. So here, the white one. Okay, so what I want you to do is that try to do these two examples, example 4 and example 5. This example 5 is an extra question. I want you to solve both of the questions, and once you finish, I want you to submit your answer and your working to me. Okay, so I can check it. Alright, so if you have any question, you can ask me. For now, thank you very much, students. I see you next lesson. Goodbye.